How's it going? This is Dr. Schulman, and this video is going to be on interdisciplinary teaching, just more about how to add more context and make connections between subjects. I know I went over this before in I guess the intro one, but I think this is going to be really useful for everybody. I'm a big fan of trying to add as many elements as I can to everything that I do. So it doesn't matter if it's uh, like a lesson on fractions or an idea about teaching statistics. I will always want to have my students writing. I always want to have my students experimenting. I always want to have my students reading. I always want to have my students learning about history. Maybe that's because I learned how to teach at a really poor school and they weren't getting a lot from their other teachers. So when they were in my classroom, I always wanted to be like, I want them to get the most out of each of these assignments. I want to make sure they've learned how to read, write, do science, do math, as well as learn about history. And that's kind of what this piece is about. So I'm sharing my screen. So if we go into this piece, this idea about interdisciplinary assignment, it's only 12 points unlike the other ones. There's a bunch of videos, but basically we're talking about all of these ideas, right? So math is usually locked into an idea of, oh, let me just download it so I can draw all over it. I haven't been drawing on a few of them, but I feel like this one, I already feel like drawing. So math is a part of STEM, right? Or STEAM. Oops. That just means we already know it's connected, fundamentally connected to a lot of other subjects. We can make everything into math. We can put data to everything. We can solve problems. And I think that's where making connections really lie. So math and science are usually fundamentally linked. And they're built upon laws, deductive logic, structures of measurement, building, and innovation technology. So, so if we're talking about stoichiometry, right? Here, I'll go over here. So I got the videos right here. So if you want to see stoichiometry, to me, this is just conversions in math, right? So it's basically you're just doing mathematical conversions for basic stoichiometry. Notice that I'm using the organic chemistry teacher. He has like the best math videos to go all the way up through calculus and statistics I've seen. There's also stuff for chemistry on population growth, for earth science, notice that we have scientific notation, which is great to learn for students, helping them see really big items or really small items. We also have kinematics for manipulations of variables. This is in physics all the time. You got to move all the variables around. It feels just like linear algebra. If we were looking at acceleration, same idea. We have pieces. The math and the science are in one. It doesn't matter if it's free fall in physics. These are just mostly, these three are physics. When I think about particle motion, right? When I think about particle motion, the first thing I think is calculus. I think the math is just linked right into the science, so why not use them, right? Why not use them? Um, Basically, for this idea, we have an acceleration, or let's just start with the distance. If I have a distance, it could be like 5x cubed minus 3x squared plus 2x minus 1. And I take the derivative of that. That's going to give me the speed, how fast I'm going. If I take the derivative of, or basically every tangent line put together, the dy dx of that, I'm going to get the speed. And that's going to be 15x squared minus 6x plus 2. And then if I go one further, I'm going to get the acceleration. So if I take the derivative of the distance, I get the speed of the the derivative speed, I get the acceleration, which is 30x minus 6. And then if we go one more, it's the jerk, which is just going to be 30. So all of this is basically how the mathematics And I guess the calculus in this case gives you everything we need to do. So I think all that stuff's really interesting. Um, but it's not just science. That's what I'm trying to say. So technology, engineering, science, they all come together. There are certain ways that we can really try to build these together. And then the arts. I know I showed you things about arts, but I might as well show you a really cool thing. This was from 2023. I went to a conference. Well, I did a virtual conference and I watched somebody use GeoGebra to make 3D images and do mass printing using mathematics and technology to create art. They created these really pretty things on towels. Obviously, she taught at a school with a lot more money than me, but they were able to 3D print these using GeoGebra and create these cool transformations. I think it's awesome. Make t-shirt designs. They bought this Axie Draw, but it created these really cool projects that they could put on what? They could put them on t-shirts, buildings, everything. So I think it was really awesome. And it just made really cool designs that they could make pictures of. If you want to do it, you can click on it. It's really easy to see I think it was with Polypad. Yeah, I had it broke down. So using the GeoGebra, draw the apps and like create it. So I just thought it was really nice. It was just another way to like use the mathematics to create art using technology. So I thought it was really well done. All right. Oh, and then for all these links, I asked the professors if I could use them. So they were fine with it. I try not to steal, but like whenever I can ask for it, I always will. All right. And if you want to, if you can't figure it out and want me to walk you through it, I will. So, these initiatives are commonplace in K through 12. So they've got STEM, they got STEAM, but this project has you use what? English language arts, science, and history. So that's the goal of this project. Can you make a math lesson that teaches English standards, science standards, and history standards all at the same time? Now, that might seem like too crazy, too hard, but it's really not that bad. I really like using that Alcozy book because it kind of does it all already. So here, let me just sorry. I'll show you some. I showed you the what's it called one. I don't know why it doesn't want to load. All right. Speaking of technology not being my friend. So this is a big chunk of that book. Don't let all cozy know that I'm sharing this with you, but you can buy the book. I think it's amazing. If you want most of them, there's half the book right here. So here's Maria Agnazzi, who I think is awesome. So they read, they learn about her history, they learn about all the languages she spoke. So although she gave her um, during social gatherings at her home, when she was young, she presented theses on a wide range of topics, including logic, mechanics, chemistry, botany, zoology, mineralogy, analytic geometry. At age 9, she gave a lengthy progressive speech advocating higher education for women. Although her presentations were made in Latin, she answered the question from the audience in their native language. So at 11, she was fluent in Latin, French, Greek, German, Hebrew, Spanish, and her native Italian. Then it talks about how she wrote the first comprehensive textbook on calculus. So this is the history. Here's the English, the thinking. Here's the math. Can you create the curve of Agnazzi? Can you do it graphically or can you do it algebraically? So this is a lesson that has history, English, math, and then we're testing two approaches scientifically. I think there's no better lessons that have all four things all at once. I'm a big fan of hers, but that's just me. Everybody's different. But that's your goal, right? Uh, Another good way to create solid interdisciplinary learning activities, math classes, is to use elements of good teaching. So math doesn't exist in a vacuum. Word problems, have students write their own word problems, right? Have them test hypotheses, have them look up. So in my classes, I had them write on their textbooks, they had to write the name of a mathematician, and then they had to learn about them. So I always want my students to have a shot at like learning about who made it. So we're trying to take these, we're trying to add context and put them in the real world. We're discovering utility and the value of content. We're learning who created the content and why, and opportunities to experiment. So all of these things I think will really help students understand that mathematics doesn't exist in this little vacuum that's connected to everything. So I think all of this will really be helpful. So if they're speaking, have pieces for speaking. A lot of times when you use like here's like a basic one. So let's just go to Desmo's function carnival. Let's just look at this just for fun. All right. Why not? So this is something I've used a bunch. I love using technology for students. I've done this a billion times. Notice that they have to answer questions. So describe what happens as precisely as you can. It's like they're using stuff, right? They're using ideas, right? Really understand that, give them a chance to write. Here's another one. So now the student has to do what? They have to basically, this is it over time, and they have to map it. They have to map what's going on. So their goal is to kind of map this thing. Obviously, I did it real fast, but we'll see how close I was in the beginning. So they get to talk about it. Then this is the graph. See the sketch tool and have them answer questions. There's no history here, but at least they're using technology. They're using scientific reasoning and they're using writing. So these are bumper cars. What might be interesting on a graph? And then actually you get to plot the graph of the green car and try not to make it hit. This is just a carnival. There's tons of these. There's like a million classroom activities in Desmos that are all done waiting for you. I like marble slides a lot. I've used marble slides a ton. It's one word. So they have it for rationals, periodics, parabolas. I've also used the mini golf. With transformations. So they have to, it's like how many moves can they get the piece to the other piece, right? How do they get it all the way around to fit there? So I think these are all really interesting things for students to do, but just giving them the chance to write is really important. All right. One example is having students create a children's storybook. So I made an example one. This was the rubric. They had a probability, area, perimeter, volume, surface area, 2D to 3D shapes, circle parts, circle graphs, and equations. And then I made a day watching the Raiders game in my class. Crazy that like 7 years later, the Raiders actually moved to Vegas, but one of my good friends was a Raiders fan. So this was my example of it. And my students really liked it. They thought it was funny. They got nachos. The cheese is all over the nachos, so it's surface area. The soda is filled with the cup. Tom Brady let the air out of the football. So what shape did it turn into when the football was flattened? A wild fan took off his shirt and spun it around. How much was it spinning? I just try to make a funny story. The person ran around the field. I got really great storybooks from these kids. They loved it. So that's just another way to like incorporate writing into it. All right, so creating large timelines, I think is really cool. So in this conference, they talk about the timeline all around the room. And they have like all the math pieces, but then they also have the students' histories, like when each student was born, important things that are happening in their life, like their first job, or when they had their like first vacation, and just like have a long timeline of like when kind of the math started and where they fit into that timeline is great. Let's see what else we have. Simply sharing the history of individuals who created the culture. So this was task 4, where they actually get to learn about how gambling was created for odds. Students find really interesting. The infectious activity behind scientific art and experimentation can create productive learning experience, gathering students' data and experiments so we can gather their data, test hypothesis, hands-on proof-based, either technology assisted. Oh, these applets are really fun. It's got the Monty Hall problem. I got simulations. We could actually see simulations in action. Cool. We can watch all these mixed number simulations. What else? We've got applets, which are really cool. So we can see exactly if we change parts of this, we can change the phasings of it. They can see all of these things work. So we've got 2D waves, a ripple tank of 2D waves. See, all these are really nice. We change the speed and really just help students like understand like what the formula are doing. I think it's really nice. So these are sound waves. We've got other types of waves. We've got light waves too. Um, and just see how they move with different dampenings on it. As opposed to the sound wave, what's the light wave do? You can change all these pieces to it. I like the sinusoidal waves, but these are really great. There's ones on linear dot projects, 2D vector fields, which is really cool. And just really helping students to see where the math comes from and how this works with lots of particles, little particles. You can change the height. We can have it with the grid. Mouse can adjust the zoom, you know. I think all this stuff is really nice for students to see. Uh, but yeah. So I think any one of these pieces would be really interesting to build into your idea. I've always done with sinusoidal waves for students because when they first learn about sine and cosine and tangent. And then we've got video.
Ready to step into the
So, oh, this is cool. So I really like this video. This is from Patterson, but it's one of my favorite Patterson ones. We could watch it.
Formula for the area of a circle. You know what it is. It's pi r squared.
I
It's
got to
little
give Patterson a
trickier,
shout out.
just visually in terms of this. So I'm going to try and create a little environment to make sense of this. So just pay attention. I'm going to take a circle and cut it into 4 quarters and kind of put those 4 quarters back to make this shape. Now, the truth is that shape doesn't look like anything you really recognize. But I will tell you it's going to get close to something you will recognize. So let's bring in a different version of that. If I took that same circle but divided it by 8 portions, right, 8 portions, and put them back to back, I think we're starting to make a shape, maybe kind of like something you might recognize. Some of us might say that's a caterpillar. I don't know. But anyways, maybe we're making something that is more like a shape we recognize, maybe not. Let's bring in another one. Let's divide it up into, I don't know, is this 12? 2, 3, 4, yeah, 12. And again, would you say that you are seeing kind of a shape, maybe a little bit like what you might recognize? Maybe not, I don't know. How about if we cut it up even into more pieces like this one? And now I think you're starting to see, wait a minute, look at that. I actually recognize that shape. This is called kind of like a limit argument, which means as I'm cutting it smaller and smaller and smaller, it's like approaching something that I might recognize and be able to work with. So if we take these out for just a second here, and we bring in maybe this, again, this movement process here. What I want you to notice is that, again, when we cut it into fours, that was no good, and then 8 was better, and then 12 and 16. Now you're starting to see a parallelogram form, aren't you? And let's learn a little bit about the parallelograms information. So how far is it from one side to the other? Well, it would just be pi, because, or sorry, it would be pi r. Why would it be pi r? Well, 2 pi r is the entire circumference of the circle. But you'll notice we're only looking at half of the circle. The other half is up here, the little bumps are along here. So this is only half of it. So this dimension is 2 pi r, sorry, just pi r. Now, what would be the height of our parallelogram? You can see it there. R is our height, isn't it? Now, here's the so cool thing. If you multiply our value of pi r times
And I'll stop him because I see this as a rectangle. So this is pi r times r, pi r squared, a circle. If we squish it, it literally turns into a rectangle. And that's how we're using just base times height for the rectangle to make the what? The circle formula, which is really cool. And then he has like another little image.
Totally. So here's the same argument, but just kind of in an animation, a rectangle.
And it
We
gets
go
more
out to
closer
8,
to
you see
the
the,
rectangle.
I went out to 20 and closer to, I could divide this up into a lot more, right? Like 14 or 16 or
So all these things are really helpful for how we go through it. So I think all those pieces of using technology it just really helps students really get their hands in it. So oops. All right. So what do you have to do for this one, right? So you're going to be teaching with an interdisciplinary approach, right? So you're going to be using different cogs to develop student learning in tandem. So this is useful because all students come to the classroom with different interests and ability levels. By utilizing different elements from the core 4 subjects, the lessons, they can find their entrance into math. So let's say they're really good at English, really good at history, really love science, that should help them with the math. So through reading, experiments, or historical background, they'll be engaged in the math content. So all of these ideas should really help, and how formulas can be generated. Is this the one I clicked on? Oh, so I forgot one, but something that I always do for my classes, I just use the proofs. I don't just teach a student Pythagorean theorem, I show them the proof. I don't just teach them XX, 2 red X. I always show them the proof. This is just one of my lessons where I show them the proof and then they get to do the problems. Sorry, I was just curious to what the other link was. All right. So the whole idea for this is requires planning of knowledge of contents in unrelated fields and being aware how to wield these together. We've got examples of this approach with steps, which is nice. You want to use their examples, that's cool. Another example is building a shelter, which is fun. So it's got math, literacy, social studies, and science. What did you build? How big was it? Just the way we can connect everything together. This set is highlighted by the parable of polygons that teaches about the vital historical ideas of racism and segregation. So this is a culturally relevant teaching approach for it, which is great. So there's tons of examples for you to look through. So what's your job? What do you have to do? You got to pick a topic and you have to put English, science, math, and history all together. Isn't that fun? So you got to define interdisciplinary instruction, either citing or providing your own definition. What are the benefits and challenges to incorporating this into your teaching? What are your own experience? Have you ever had one? I know that I did a summer program where it was all about STEM. So students got to pick. They're gonna do 3D video games, rockets. Oh my God, I can't remember the other ones, but I was just teaching the math. So I had to teach the math of 3D game design. I had to teach the mathematics of rocketry, whatever it was, but they had to do English articles on rockets. If it was a rocket one, English articles. They learned about rockets. They read articles about it. History class, they learned about the history of like going to space. Science, it was all the science behind it. And in math, with me, they had to build it. They had to use the math, do the formulas, and build it. So it was pretty cool. So that's what experience that I've had with it. If you want to learn more about that, I can share that one with you. But that's where they actually had to build the rocket and the altitude tracker to figure out exactly how high the rockets went up. And I have videos of my students being really bored shooting them up because doing rockets for like a month. Every group was not happy by the end. Do you believe that as an educator you need to excel in the other disciplines in order to incorporate in your teaching? Why or why not? Do you have to be great in English to like teach English ideas? Do you have to be great in science? I don't know. It's up to you. Is it a math teacher's job to teach students how to read and write, understand historical facts, experiments? Why or why not? Do you believe grades in math class should be affected by writing and punctuation? I do, but I'm not like everybody else. So do you think that the other pieces should affect the grade on the math project? So you get a grade, a standard, describe in detail your plan for the activity, how long it should take. Will this be 3 separate activities or one big activity? Explain the directions in detail. What are your students doing? Describe common misconceptions, how your students be graded, how you check for understanding. So the first one is English. So what's your ELA standard? Is there reading, writing, speaking, or listening components? Are you going to go over syntax, grammar, punctuation, diction, word choice, or vocabulary? Why did you choose this strategy to promote ELA? How does the ELA strategy help the math? The same thing can be for history. So are there historical readings, biographies, primary, secondary sources? I know in my class, my students did a really cool thing where they got, I've got a whole list. If you want history sources, I remember I was teaching technology for teaching, and my students came up with these really great sources for like incorporating technology into history class. I thought it was amazing. Will you go over current or future uses of the content in various fields? We discuss technological advancements developed throughout history. Why did you choose this strategy to promote elements of history? How does this historical-based strategy promote the comprehension of the math? Then you get the science standard. So will you utilize the science standard? Yes or no? Experimentation, formula building. Are they hypothesis testing? Are there hands-on simulated labs? Will you go over deductive reasoning and the scientific process, gathering data, sharing results? Why'd you choose a strategy to promote elements of science? How does the science help the math content standard? Then you get to reflect on it. Do you think you would use this in your classroom? If so, how often? I always use English. I always use history. I use them all the time. That was just me. Do you think interdisciplinary teaching is just good teaching or another type of approach to employ when necessary? Explain what it was like to complete the assessment. Did any of your thoughts about interdisciplinary teaching change while completing this? And then the important stuff for me. How would you improve or alter this assessment? If you were to make this for pre-service teachers about interdisciplinary creation, what would it look like? And these are the math standards and the in-task standards that it goes on. So I hope that was useful. I should show you the rubric as well. I was curious what else popped up. So here's your rubric. The introduction. So your clearly defined instructional lens and descriptions of its use within the classroom. So what's your definition of interdisciplinary teaching and how do you incorporate it? The activity. So how did you incorporate it across the subjects as well as your reasoning for how it helped understand the math, your reflection on it, and how well was it formatted? So here's the rubric to do it. And I hope this was useful. And if you want to see more about any of these ideas, just feel free to reach out to me. I got all the stuff for the rocketry. I could actually show you where that came from if I have access to it. I don't remember. There's so much stuff in here. I'm gonna just look up rockets. Is this part of it? I'm just curious to what's in here. Okay. Was this it? I know it was where I have the altitude tracker. If I can spell altitude, that'd be nice. All right, I'm gonna check one more place. Just to be like, I can show you this if you want to see it. Here it is. Cool. So I do have it. Here's the STEM workshop. So if you want to see this, if you're curious about learning more about it, I'll share this with anybody. So these were the three. One was 3D printing and additive manufacturing, and I actually 3D printed. One was AI programming. And so I had to do math of AI course, a 3D printing of math, and then I had to do a rocket one. I just remember the rocket one because the students hated it. So this is the science ones, the history of rockets, how does it work? Here's the math pieces here, is how to make it. Here's the science behind it. Here's the math behind it with the trig, and then there's the workshop. So yeah. So this is how you can put this all into one. I just thought I'd show you one. I just remember building these and my students were not excited about it, but we made them and we made these pieces and we saw how high they went and figured out exactly how high the rockets went based on their altitude trackers. So I don't know. I thought it was pretty interesting, but at that point they were sick and tired of rockets. So really think about having the same thing across subjects. So me personally, I think it's great to do it in one class, but if I go to English class and everything's the same, then I go to social studies class, everything's the same, then I go to science class, everything's the same, and then I go to math class, I think I'd lose it without the lack of variety. But it's just me, right? Everybody's different. So if you want access to this one, these workshops, just feel free to reach out. The math that I did for this was pretty interesting. But yeah, I hope this was useful to you. I'm excited to see what you come up with if you did this one, and enjoy your day.